A man starts walking north at a speed of 1.5 meters per second. A woman starts at the same point, P, at the same time walking west at a speed of 2 meters per second because she's faster, obviously. At what rate is the distance between the man and the woman increasing? So the best thing to do here would be to try and draw it out to even see what maybe it looks like. So we're going to do a point P, and we're going to be quiet. Now, a man starts walking north. At 1.5 meters per second. And a woman starts at the same point, walking west. At 2 meters per second. At what rate is the distance between the man and the woman increasing? So what is this forming? Triangle. So in order to do these, life is so much better than what you're making it to be. Okay. So I'm going to label this X, Y, R, because I like it. So you have to stop talking. Because I felt like labeling them whatever I wanted to. I'm going to label this one you can label them whatever you want. I'm going to label this one to prove a point. I'm going to label it you're an idiot. It's a lacrosse stick. Or it's a spatula. Spatula. And then this one's, or a fly swatter. And this one's going to be a railroad crossing sign. So the catch here would be, if you were using your formula, you would have r squared equals, oh goodness, spatula squared plus railroad crossing sign squared. All right. So what do we always do? Well, we know that in order to find, what's it asking us to find? So dr dt, right? Do we have dr dt right now? How can we get dr dt? We have to do the derivative of it. Because when we do the derivative of r with respect to time, you're going to get a dr dt behind it. So we have 2r times dr dt using power rule equals 2 spatula d spatula over dt. Oh, come on. My smartboard's making me not happy. Plus 2 railroad crossing d railroad crossing over dt. Okay. All right. So what's the catch here? I told you guys, we're solving for dr dt. What must we know? Right. So we know d railroad crossing over dt. What is it? 1.5 meters per second. Because remember, whenever you have This would be the length per time, right? So that's how we know we have d railroad crossing dt. D spatula over dt is going to be 2 meters per second. We're looking for dr dt. We don't know it. Okay? Now, we need the r, the spatula, and the railroad crossing in order to be able to solve this. Just the basic ones, just the side length. So we need to know this side length, we need to know this side length, we need to know this side length. How could we figure it out? Pythagorean theorem means we need 2 side lengths first. We don't have any side lengths. Yes. At what rate is the distance between the man and the woman increasing 1 minute later? So, at 1 minute, what's the side length of the railroad crossing going to be? 1.5 times 60. So what's that? 90. It's just 1.5 of 60. And then a little spatula or yield sign, I don't know why it was spatula, but it was whatever, is going to be 60. Oh, 180. Ooh, 120. Man alive, this is getting worse. I looked at the 90 and times it by 2. 120. Because it's 60 times 2. How can I get R? Pythagorean theorem. R squared equals 120 squared plus 90 squared. So R squared equals I have no idea what the square root of that is. And you'd have to guess and check. So what's R? Yeah, what is it? So we'll go 320. So now we have everything but dr dt, so we can figure it out. So 2 times 320 meters dr dt equals 2 times 120 meters times 2 meters per second plus 2 times 90 meters times 1.5. Oh, someone lied to me. That's okay. Is this just wrong? Or is this right? Okay, what is it? That's why I said it might be wrong. I went 0 and then 0 and then 5 and then 12 and yeah, it's a problem. Good. All right. So what is it? 150? Good. I just said 150. So you're going to get 300 meters equals 240, 480. And 80, 360, 450. What's 2 times 90 times 180? 180 plus 90? 270? Ha! 270 meters per squared per second. So you go 480 plus 270 divided by, so what's 480 plus 270? Why do you have such issues? Like you did it anyways. When you divide it by 300, what do you get? The meter and the meter squared cancel, which is good because I need meters per second, right? What's 750 divided by 300? Something, but it has to be 2.5. And that one you could do in your head because 300, then 600, then you have 150 away, so that's another half. So it'd be 2.5. You can do that in your head. Okay. This is going to be your ladder. Side view. It's great. A ladder 4 meters long rests against a vertical wall. If the bottom of the ladder slides away from the wall, so dB dt, I know it's going to be per time because it's distance per time, right? It slides away from the wall, so it's going to be positive 30 centimeters per second. How quickly is the top of the ladder sliding down the wall? So they want I'll call it A. dA dt. When the bottom of the ladder is 2 meters from the wall. It should say 2 centimeters. So, oh, where's this? This one should be meters. That's just a typo. It's meters per second. It's flying. Be afraid. Alrighty. So, what can I figure out? You can figure out what A is by doing what? Yeah. So you're going to do, I'll just do this as L. So you can do L squared equals A squared plus B squared, but we're solving for A. So A squared equals L squared minus B squared. A squared equals 4 squared minus 2 squared. A squared equals 16 minus 4, so 12. And then we take the square root of it. Now you can take plus or minus when you take the square root of it, but it's a length, so it's going to be positive. Square root 12, which you're in turn going to change to 2 root 3. Two root 3 meters. Okay. So we're using Pythagorean theorem. L squared equals A squared plus B squared. Do the derivative of it. So we get 2L dL over dt. equals 2a dA over dt plus 2b dB over dt. Most people get to this point, fill it in, and then stop. Because we don't know what? We're trying to find dA over dt, but we need what else? We have dB. We're missing dL. And a whole bunch of people will sit there for forever and say, I don't know what it is. It's the rate of change of the ladder. It's 0. It doesn't change. It's a ladder that's 4 meters long. No. This is just, yeah, no. This is a 4 meter long ladder. It's not changing. So dL over dt equals 0. So if ever you have an object that is not changing, remember that its rate of change is nothing because it's not changing. That's where people error. So we're going to get 2 times 4 meters. Oops. Times 0 meters per second. So it actually all cancels. Equals 2 times 2 root 3 times dA over dt equals 2, oops, plus 2 times 2 meters, well, this needs a meters too, times 30 meters per second. So we're going to get 0 equals 4 root 3 meters dA over dt plus 4 times 30, which is? So we're going to have to subtract that 120 meters per second over first. Now, in order to do units properly, when you divide by the 4 root 3 meters, I'm going to write it out sideways. Oh, this is meters squared. Sorry. This is meters squared. Because it's meters times meters. So you can get negative 120 meters squared per second times 1 over 4 root 3 meters. Or if we rationalize that, so we have negative 30 over root 3. We can multiply by root 3 and root 3. So we're going to get negative 30 root 3 over 3, which reduces to negative 10 root 3. So people will fight me and say, I need my calculator, I need my calculator. How would I punch that into my calculator? You didn't need your calculator for any of this. You're going to leave it as exact values. So your prof doesn't have to give you a calculator. You have a square. This side length is the same as that side length. It's a square. There's no length and width. Side length and side length. So the side length, it says when this side is 3 meters. And people are like, I don't know if that's ds over dt or just s. It's just meters. It can't be ds over dt. If it's ds over dt, it'd be meters per second. That's the giveaway, okay? So s is 3 meters, which means this s is 3 meters. So you could do s times s. So area equals side squared. So it's going to be dA over dt equals 2s ds over dt. And they're asking for how fast the area is, so you just fill it in. It's going to be 2 times 3 meters times 0.8 meters per minute. So what do you get? dA over dt equals what's 6 times 0.8? 4? The derivative of a is just 1. Because it'd be 1a. And then you write behind it dA over dt. Like if I asked you what's the derivative of 1x, you'd tell me it's 1. So what's the derivative of 1a? Well, it's 1, but I have to follow behind with dA over dt. So the a actually goes away. If it was 1 length, yeah. So what is it, sorry? 4.8?